Bruce and I've got the dog on the floor, and today we're going to continue to merge in our boundary. If you'll remember, we were working on the out of bounds condition where if you tried to move a piece to the left, we would keep the old version and the new version and whether it was valid. And since this move to the left puts a few of the points off the left-hand boundary, we would abort. And basically we'd go from a sad, inconsistent state to a happy state because we aborted maintaining the old value. Well, if you think about it, Tetris is a game where when the tetromino goes all the way to the bottom, it can also collide with other tetrominos and go out of bounds. Well, going out of bounds in this way means that we're taking a piece off of the lower boundary, which is a y greater than 20. So what we're going to do in that case is actually very similar. Let's look at the code. Okay, so this is the function that we're using to move. So we're grabbing the old version, we're trying to move it, and then we check to see if things are valid. And so then we can try to move, and if the move is successful, if it's valid, then I keep the new one. If it's not valid, I abort and I take the old one and I'm happy. But if you think about it, merging into the bottom, into this junkyard that we have here, is going to look very much the same. We're going to take the old, the new, and check to see if it's valid. And if it's valid, we're going to go ahead and keep moving down. If it's not valid, that means a collision has happened, and we're going to keep the old version, but we also need to merge in. So we're going to need another version of this code. So let's go ahead and extract that now. And let's call that move data, and that's going to take a game and a move function. All right, and we'll just drop this right in place, and then we'll return the old, the new, and the valid. Okay, so I think that's all that we need to do, and basically we could use our extracted function this way. Old, new, valid is equal to move data, and I'm going to take the game and a move function. That looks good to me. So now this is moving down, happy as a clam. I can shift to the right, I can shift to the left. Let's make sure everything is happy here. Everything looks happy. Okay. So now I'm going to go ahead and absorb this function, and I'm going to allow move downs the same way. So we've extracted our move data, and that's great. And now we want to move down. And so we're going to steal this move down because this becomes the one that we're actually going to process, right? So the first thing that needs to happen is we're going to have code that's shaped a lot like this, right? We're going to try to grab the move data, but you can see that we don't have a move function anymore. So we're going to grab the tetromino one that looks like this. It's not left though, we're going to move down. Great. So we have our move data, and we need to decide what we want to do. So I'm going to say choose move down or merge. And this is going to take a game. It's going to take the old, new, and it's going to take the valid. Right? And so this will be a reducer over game. It'll take a game, it'll return a game, and it'll basically, what should we do if everything is okay with the new version? Well, we should go ahead and move it down, right? So let's implement that. I probably don't need the choose in here. The move down or merge. So that's kind of like a maybe. So move down or, and this is going to take a game, old, new, and a true. And let's label that. Or I will forget. Nah, this is good. We can just do that right in place right there. So now we're moving down. We don't care about the old one anymore. So it's going to look something like this, right? So it's actually going to look a lot like this, right? So move down or merge. So this is the maybe move old, new, and whether we're valid or not. So it takes the tetromino, it does the move, and it does the show to put the points in there. Let's see if that looks okay. Undefined function old and 39. Yeah, so we need the old and the new. So I already know that I need to keep the new one, right? So the tetro that I want to grab is the new one, right? So this basically says that I want to keep the new tetromino, and then I want to do a show. Okay, let's see if that works. Yeah, so now we're moving down and we're using our new code base, and let's see if it works correctly. Okay, so now probably the best thing to do is to start working incrementally on the case where we have to merge. Def move down or this is going to take a game, an old. Do I care about the old anymore? I don't know that I do. Actually, I do. I do care, right? Because this is going to become the one that we merge into the bottom. And I also care about the new. Do I care about the new? No, because that is had a collision. We can't make that move. Okay, so now what we can do is something like this. I could say game. Right? And then I can say merge. Merge, and then so the merge is going to take the old tetromino, right? So basically when something hits the bottom, we have to take the game, we have to merge the old tetromino into our graveyard, we have to build a new tetromino, and then we need to show it to put the points in there. So def merge So right now, we're just going to make that return a game just because we want to make the reducer keep working. So this doesn't do any work, but it doesn't break anything because we're just passing the game straight through, right? So these are all games. This will just be an unchanged game. Eventually, this will be a game that puts our data in there. So let's see if things are working. So we're going down, down, down. Okay, undefined function, new tetro. So the new tetro, new tetromino. Right, like that. Okay. Okay, so that's working. Okay, so what's going to happen is this will hit the bottom, and theoretically it'll fix itself. But right now, we're actually taking advantage of the check that's in the other system, and that's actually not working precisely. So let's pull that check out of the live view. So we'll take this live view, and we've got this check that actually is managed on down, So yeah, so you see the location hits 20. We build a new tetromino. So I don't want to do that anymore. So that's good. So here we're calling game.down, and that's, so what should theoretically happen now is this should keep moving down and down even after it hits the bottom. Right? Okay, so now we're going to the bottom. So what we need to do is we need another kind of collision, and that's coded in points. We need to find out if we are out of bounds, right? So we have another out of bounds condition when y is greater than 20, we're out of bounds, right? So this is like that, that's like that. Yeah, so now let's reload this. And this is going to hit the bottom, and hopefully it'll give us a new tetromino when we're at the top. And bang, there's a new one right at the top. That's most excellent. So this is probably a good time to take stock. Okay, so what's happening is we have these pieces that are falling, and when they hit the bottom, the new tetromino is popping up to the top. And what eventually needs to happen, in our game, we have this thing called junkyard, and we need this junkyard to start to grow so that we can start rendering points and that we can have more advanced checks for whether something is a collision. So that's probably a great thing to do for next time. So the goal for next time is for us to start stacking the old tetrominos in the middle of the screen. And then a stretch goal for one or of the next couple of lessons is to actually start interacting with those ones that get stacked in the middle of the screen. So this is Bruce and the dog on the floor for Groxio Learning.